3-7 is about the real numbers, and the real numbers are broken up into two parts. And these two parts are the sets of rational numbers and irrational numbers. If you remember, rational numbers is any number that can be written as a fraction, any number, positive or negative fractions. And irrational numbers are just numbers that cannot be written as a fraction, like pi. Pi is probably the most common irrational number that they use as an example, or the square root of 2, the square root of 3, the square root of 5. All of those square roots of non-perfect squares are irrational numbers because they end up being decimals that keep going, alright, what they call non-terminating decimals. Rational numbers can be broken up again into two more groups. It's all of the numbers that can be written as terminating decimals and all of the numbers that can be written as repeating decimals. Remember, both of these numbers can be turned, or these types of numbers can be turned into fractions, so therefore they belong under the group of rational numbers. Non-terminating decimals obviously belong to irrational numbers. Terminating decimals can be broken into two other groups, alright, which are the non-integers. Right, these are positive and negative numbers that have parts to it, so they're written as a fraction, and then integers. And remember, integers are positive and negative whole numbers, or whole numbers and their opposite. So there's no fractions in there, whether or not they're positive or negative. As long as it's a positive and negative whole number, that's an integer. Positive and negative numbers that are that can only be written as fractions and decimals are what they call non-integers. Okay, integers. By the way, I had to continue the slide on another slide. So integers can be broken up into two more sets, and that is a set of negative integers. So those are the positive and negative. The negative integers. All right. So -1, -2, and so on and so forth. And then the whole numbers: 0, 1, 2, 3, 4, 5, 6. So the positive integers are the whole numbers, and that's what integers are broken up into. And now, whole numbers can be broken up into further sets. But this set right here has only one thing in it, and that's 0. Alright? And then it can also be broken up into what they call the natural numbers. And the natural numbers are just your +1, +2, +3, starting at 1. So 0 is a whole number, but it's not a natural number. So that's why it's its own set. And that's pretty much it for the sets and subsets of real numbers all the way down from rational numbers down to natural numbers. The first part of worksheet 3-7 is asking to write all the names or write all the sets that the number belongs to. Alright, so I'm going to take the example -3/5. Well, again, I wrote down all the sets that we're going to try to plug it into and see if it fits. Well, natural numbers are just numbers that are 1, 2, 3, so they're whole numbers without the 0. Well, that's a negative fraction, so therefore it is not a natural number. Alright? Whole numbers, 0, +1, +2, so again, positive numbers. This is a negative number and it's a negative fraction, so it's not even whole and it's not even positive, so it's not a whole number. Integer, positive and negative whole numbers. Well, this is a negative number, but it's a fraction, so it's not even whole, it's part of a whole, so therefore it's not an integer as well. And then it comes to irrational numbers, and rational numbers are any numbers that can be written as a fraction. This is a fraction, alright? So yes, it is a rational number. Is it irrational? Well, it can't be rational and irrational at the same time, so it has to be one or the other. So therefore it's not irrational. Since real numbers are made up of rational numbers and irrational numbers, so therefore it is a real number. Alright, so that means it's this one right here, rational, and also real. Okay, so for our next example, we're going to take a look at the square root of 32/2. So one of the things you guys might want to do, if at all possible, is simplify the number if you can. So if you look at that, you think, hey, that's just a real number because it doesn't look like I can simplify that. It's a fraction, so it's not natural, it's not whole, it's not an integer. It could be rational. It probably is irrational. So first thing to do is see whether or not you can simplify it. So I'm going to take a look at what's inside what they call the radical. And again, the radical is a square root symbol. Inside the radical is 32/2. If you simplify 30/2, that gives you 16. So now you just got to figure out what's the square root of 16. And hopefully you don't need your perfect square list for this. I hope you understand that 16 is a perfect square. So if you took the square root of 16, it's going to be 4. So that is the number of the simplified form of square root of 32 over 2 is 4. So now we can actually start taking a look at whether or not it's a natural number, whole number, and so on and so forth. 4 is one of the counting numbers, so it's natural. It's also a whole number. It's a positive number, all right, that doesn't have any parts to it, so it's an integer as well. 4 can be written as a fraction 4 over 1, so it is rational. Because it's rational, it cannot be irrational. Again, it cannot be both rational and irrational. And then, of course, you have the real numbers. Since it belongs to rational, it's going to be a real number. So the square root of 32 over 2 is, again, all for 5 of these: natural, whole, integer, rational number, and real. The second part to 3-7 is asking to state if the number is rational, irrational, or not real. It cannot be all 3 at the same time, or even 2 out of the 3. It has to be one of the 3. So let's take a look at the example 3, the square root of 21. Okay, the square root of 21, I don't know if you guys have practiced this enough. You take a look at 21. Is 21 perfect, a perfect square? If not, finding the square root of 21 is not impossible, but it's going to be one of those non-terminating decimals. So that means it's irrational. So it's got to be this one. It can't be a rational number because it's a decimal that goes on forever, so you can never figure out what that last digit is to turn it into a fraction. So it's not a rational number, so it's called an irrational number. So that's what it is. And since it's part of the irrational numbers, then it is a real number, so it's definitely not a not real number. Alright, so that's how you would do that. It's an irrational number. If you were doing example 4, let's take a look at example. Okay, so example 4 is going to be like the square root of negative 4. Alright? Let's compare this to the square root of 4. The square root of 4 I know is 2, because 2 times 2 is equal to 4. Actually, all square roots have two answers to it. It's also negative 2. Wait, hold on. It's 2, because 2 times 2 is equal to 4, right? And then it's also equal to negative 2, because negative 2 times negative 2 is equal to 4. Oh my goodness. Alright, sorry for the interruption, but let me go back to this. So, square root of 4 is either 2 or negative 2. So now my question is, what is the square root of a negative number? Doesn't matter what the number is. In this case, it's negative 4. What number times itself will give you negative 4? Well, if you think it's negative 2, think about that again. Negative 2 times itself is equal to a positive 4. So that means it cannot be negative 2. Alright, so it's not that. So what kind of number exists that when you multiply it to itself will give you a negative number? Well, there's no such real number that exists. So therefore, this is what they call or this number is not real. Alright, so this is a not real number. When you guys get into Algebra 2, possibly Algebra 1, they call these numbers imaginary. Alright, so the square root of negative 4, in fact, the square root of any negative number is an imaginary number or a not real number. So give these numbers a shot, these problems a shot on 3-7. Try your best. Some of them are asking you to find the real numbers in between the pairs of numbers, and you guys should be able to pick out a real number that's in between that. Alright, I think number 15 says find a number between 7 and 3/5 and 7 and 4/5. Find a number in between that. Alright, I'm pretty sure you guys can find a real number that belongs in there. Okay, thanks. So good luck.